Hi, welcome to new Cube video. My name is Pavel Savyanko, and today I show you how one defines new subsets in system tree and how one uses them. Let's go. Okay, we are back into our terminal, and I would like to show you how one defines different subsets in a system tree of CubeGUI and for what it is useful during performance analysis. So let's start Cube and select example of Cube file. So this is a result of measurement of NAS benchmark, BTMZ, nothing special. We get here our metrics, time, visits, execution, and so on. This is trace analysis. It's now irrelevant and just a side note. So we have the metrics, we have our call tree with different calls, and we have here MPI calls, we have here OpenMP calls, so also absolutely typical HPC application, and we have a system tree. So place of interest today is our system tree. So if we expand it, going on right click menu, context menu, expand all, and we can see that it was carried out on machine, on lakes, on these nodes, and it had the measurement had 64 MPI ranks, and each of them had 4 threads, OpenMP threads. The system tree is relative, actually very homogeneous, so nothing special. In this case, the system tree or this measurement was relatively small, and we can overview the obtained result relatively easily in the system tree by scrolling over it, and it is still manageable. So we can see that here is, for example, if we go select the scroll path, we see that here is aggregated value like 3.3, 3.2, here is under 3 seconds, here is 3.5. It's approximately all the same, but one can relatively easy overview the data. If one goes or makes a more realistic measurement or more useful measurement with way bigger configuration, one obtains then easily system tree which has 10,000s and 100,000s of entries, and then it will be absolutely not possible to take a look at this data in this manual manner by scrolling through the system tree. So for that one goes away from such manual browsing and uses different methods, for example statistical methods, and CubeGUI of course offers also the tools to do statistical analysis, like for example this plugin, statistics, and about plugins in CubeGUI I will explain in another videos, so subscribe and get notifications to not miss it. But here I will use it only to demonstrate without going into details. Here is the only important is displays a box plot, it displays a maximal value, a minimal value, medium, mean, and the quantiles. Or if we click, then one gets this data also in a text form. And details we don't go into this plugin. Watch out on the next videos. So I will just use it only for demonstration. Okay, so for every statistical analysis, one has to have a data set over which one builds up statistic, and that is exactly what this subset means. It is a set of entries in a system tree which we are using to build up statistic. Like to demonstrate it, let's do like this. I detach plugin, which I also will show you then also in another video about plugins. Let's have it like here and make it always on foreground. Okay, so where do we find this subset, or how do we do that? So first of all, if we go down, we see that here combo box, and it has 7 predefined entries. These are predefined subsets which we offer from the very beginning for the user as default values, and one can maybe then select them already. Maybe it's already enough. So which are these subsets are? Now, first of all contains of 256 elements, which is 64 times 4. So this is basically all threads in the system tree, or leaves, if you want so. Why leaves? That comes from the structure of the system tree dimension. This I will explain in yet another video about data model in Cube. So get notifications and do not miss it. It will be done in a series of Cube videos about Cube library or Cube data model. Okay, so by selecting this subset all, basically all these elements are taken into the statistics, and here we can see that maximal value is 3.47 something and minimal is 266, which is somewhere here in this element somewhere. That is an example how one has difficulty to browse over such homogeneous data already by this size. There are other ways how one can find minimal and maximum values in a system tree. This I explain again in another video about display modus. Okay, so if we go then take a look at another subsets, like for example visited. What is visited? If we select, we see that all elements are marked yellow because they mark actually the entries of this subset. So in this case, again, these are very same like in the previous, in all. But why there is a visited and why all? Because this particular subset consists out of the values which have, or out of the elements of the system tree which have non-zero value in metric visits. So what does it mean? If we select the metric visits, we see that in a call path AD, we have here non-zero values everywhere. So that's why it is identical to the subset all. But if we select, for example, call path MPI barrier, we see that metric visits has values only in the master threads, because the MPI calls are carried out only by master threads in this particular setup. If one uses another setup of the MPI library, then it would be probably possible to carry out to call the MPI calls from not master threads, but in this particular example, they were executed only by master threads, and we see that only master threads are building the subset visited. So if we select then our metric execution, for example, we see that the statistic is different now. So maximal value is 0.432, which is somewhere here across the tree. I don't know where it is, but it's definitely somewhere there. And minimal is 0.00109, also somewhere here in the metric tree. And if we select another call like ADI has OpenMP calls. They have been carried out by every thread, and we see that the metric visits had entries everywhere, and therefore it is identical to the subset all. Okay. If we select the metric, the subset process, we see that it consists out of the processes and not the threads. So it's one level higher. One sees that the values are actually 3, 2. So what does it mean? For that, one has to collapse basically all this all this level. Here one has to select process 2, and then like this. Yeah, okay, I will not do that to the end. So we see that the maximal value is then 13.8474, minimal is 10, and that is somewhere here on this level. So this value 13 is a result of, in this case, aggregation, so summation over this this value. So 4 times 3 plus this one gives you approximately 13. So in this this is the statistic over the values on the level of process, of over the aggregated value over of all threads. If we go then to the metric, to the subset thread, here we have to select it here. It will be then again in our case identical to the subset all, because we have only CPU threads in our measurement. If we would have a measurement which would involve GPU, then we would have next to the OpenMP threads probably GPU locations, and then the all subset would differ from the thread. What does it mean, difference between OpenMP locations and GPU locations? Again, this I explained in a video about the structure of the data model in the cube. So subscribe and get notification. Okay, so if I then go to another subset, that is the thread 0, consists out of 64 elements. This is this subset consists out of the only master threads. So it has nothing to do with the metric visits. It only defines that threads 0, master threads, are building up this subset. And again, for this call pass, we see that maximal value is 3.4, and here is the 2.6. If we select something else, also the statistic changes, of course. Okay, if we then take a look at another subset, it is thread more than 0 or larger than 0. It is related to the ID or rank of the thread. In this case, it's every thread which is not master thread. So basically non-master thread, slaves, workers, however. So and then we see that the statistic has changed as well. So we see that maximal value is 0.1, minimal is 0.04, somewhere here in the system tree, with a different median and quantiles. And the last one subset which we offer is the tree node, consists out of 9 elements. This basically the values on the every level above our processes. So basically the values which are on the level of nodes. That is most let's say special subset, because it consists out of the values on different levels of this tree, and then statistic is let's say maybe wrong, because the values are on this level are let's say in the order of 8, 8, 9, 10, but if you go on this level, this is aggregation of all these values, so it will be suddenly 56. So comparison, it doesn't make much sense to compare the value of this 56 with these values. It will of course build up such strangest box plot, but it is useful if one has modified the system tree, performed so-called flattening, and created only system tree with only one level above the processes. This demonstration I will do in yet another video about tools where one can perform this operation in order to be able to compare measurements on different systems. Yeah, okay, these are predefined subsets. Can we define our own subsets? Yes, we can. And here I would like to demonstrate you how it goes. So let's see, select all, and oops. So subset is defined based on the selection in the system tree. So let's say I would like to have a statistic over the data of first 3 MPI ranks. For that I have to select all elements from this MPI rank. So let's do like this. I did it just manually with mouse, 4 ranks, let's say. So this is my multiple selection, and I have to define subset. For that I click with the mouse right button over it, and I find in context menu define subset. So I click and I see let's call first four processes, and then my subset is included into this selection. Okay, it is now not in this plugin. Probably that is have to fix it, but for that it is enough if we just detach it again. And then we see that this our defined subset is also presented here in the selection. So we can select it, and then we see that maximal value in this selection of this elements was 0.7. It's probably this one, and the minimal is 0.04, which is probably this one somewhere here. This one. Yeah, so this is statistic over this subset. Now, of course, manual definition of subset in such manual way or in this manner is very tedious and leads to a lot of mistakes. So let's see, if I would like to make a statistic over every OpenMP threads with rank 2. So I would have to, if I would like to do it manually, I would have to select every OpenMP threads carefully, and at some moment I would of course mistake, and or if I will suddenly release the control button, I lose this selection and at all. So for that there is better way. We will use functionality find, which I explained in one of the first videos. Take a look in the history, and we can define then our subset. Let's see how it goes. We go here, find items, and it's pre-selects me already the selected name. So in this case it would find only this element. That's not enough, so we have to make it more general, and this regular expression. So we just replace this element by any. If we have here question mark, it would be only from 0 to 9 or to 6, and if it is here to all others. Yeah, so okay, if we click, so it selected, it found basically every second OpenMP thread and marked it with yellow color. And if we go here down, we see that here is select found, and by selecting it, it creates multiple selections. So basically it selects all these elements. And now we can proceed as usual. We go in context menu, and we do define subset, and we do we call it every second, something like that. Check. And again, this subset is now available in this selection, every second thread here, and let's detach it again. So we see that it has selected every second thread, and here we have our statistic. So we see that the maximal value is 0.1 something, and minimal is this one. Yeah. There are, of course, different ways how one works with statistic and how one finds this maximal and minimal value. One can work with this display emojis, which I will explain later, or use another plugins. This was explanation how one works it out using subset in a system tree. I hope you like this video. Subscribe, write a comment, and give us a like. And see you next time.